in different ways. And this scholar is the great Indian mathematician Sri Srinivasa Ramanujan, and it is his birthday on 22nd December that is celebrated as National Mathematics Day. I welcome each and everyone to the program Ramanujan Smriti, a lecture on National Mathematics Day organized by Max Club FISAT on behalf of the Department of Science and Humanities. I invite Ms. Sina Varghese, staff in charge of Max Club, for the welcome address.
Good afternoon, one and all. It's my pleasure and privilege to welcome you all to this event, Ramanujan Smriti, a lecture organized by Max Club FISAT, Department of Science and Humanities. First of all, even in their absence, let me welcome our chairman, Anita Madam, and our principal, Dr. George Isaac, sir, to this event. Next, let me welcome Dr. C. Sheila, Vice Principal and HOD of Science and Humanities Department. She is the pivotal force behind all the activities of Max Club FISAT. It was her vision and enthusiasm that led to this remarkable event. Welcome, ma'am. Now, I welcome our Dean, Dr. Sunny Kuriakos, who has been supporting us in all our activities of Max Club. Welcome, sir. Now, I welcome today's chief guest, Mr. Ranjit Prasad, to this event. A warm welcome to you, Mr. Ranjit. Next, I welcome all heads of department present here to this meeting. I welcome all faculty members of Science and Humanities and other departments and all non-teaching staff present here to this meeting. I also welcome all our former Max Club members to this meeting. Finally, let me welcome our dear students for whom this program is being organized. Welcome, my dear students. Once again, I welcome one and all to this program. Now, let me introduce today's chief guest. I'm very proud to introduce today's speaker, Mr. Ranjit Prasad, who is an alumnus of our college. He graduated from Easy Department in the year 2018. Apart from his academic excellence, he was an active member of Max Club FISAT from its very inception. Motivated by his teacher, our dear Shinoy sir, he participated in more than 50 competitions and math fests. I proudly recall that Ranjit and his team were the winners in more than 25 competitions, and most of them even beating BSc Mathematics students. I am sure that Mr. Ranjit and his friends were able to explore the beauty of mathematics to a large extent during these quiz tours. Mr. Ranjit got placement in the 7th semester itself. He worked in XLSI for 1 year, but his unending quest for knowledge led him to the gates of IIT. Presently, he is doing his MTech in research in computer science at IIT Jammu. On behalf of Max Club FISAT, Department of Science and Humanities, and all your beloved teachers, I welcome you, sir, to this event. Now, may I welcome Dr. C. Sheila to speak a few words. Ma'am?
Sina, can you hear me? Okay.
Yeah.
Due to an emergency situation, I am out of station. Sorry. Okay. Is the coordinator of this program, Ms. Sina Varghese, our respected principal, our respected chairman, all heads of departments, all dignitaries, our resource person, Mr. Ranjit Prasad, and my dear students and my dear colleagues. Good afternoon all. First of all, I wish to congratulate the organizers of this program under the guidance of Ms. Sina Varghese. And as far as FISAT is concerned, this is a proud moment for all of us, as we are very fortunate to have with us our Ranjit Prasad, the former Max Club secretary, as resource person. I wish to congratulate Mr. Ranjit Prasad, and I would like to express our sincere gratitude to Ranjit Prasad. And thank you all for organizing this such an event, and wish you all success for all your future endeavors. Thank you.
Thank you, ma'am. Thank you, ma'am.
Yes.
Thank you. Next, I invite Dr. Sunny Kuriakos to speak a few words. Sir.
Is there any problem with the audio?
No, sir. You're audible, sir. Sir, can you hear me? Sir, can you hear?
Seena and Sunny sir,
Yes, sir.
let me leave the function, okay?
Okay, miss, thank you. Thank you for
Seena?
joining us. Thank you, ma'am, for joining.
Hello, Seena.
Hello, ma'am. Am I audible? Miss, കേൾക്കുന്നില്ലേ?
Yes, ma'am. It's audible, ma'am.
Thank you, Sheila, ma'am, for joining.
സീന ഞാൻ ഒരു എമർജൻസി ഇതിലാണ് ഓക്കെ ഞാൻ അത്യാവശ്യമായിട്ട് പത്തനംതിട്ടയിലേക്ക് വന്നിരിക്കുകയാണ് എൻ്റെ മദർ ഇൻ ലോ ഈസ് നോട്ട് വെൽ ഓക്കെ ലെറ്റ് മീ ലീവ് ദ ഫംഗ്ഷൻ ഓക്കെ ഓക്കെ താങ്ക് യു രഞ്ജിത് പ്രസാദ് ആൻഡ് താങ്ക് യു സണ്ണി സാർ ആൻഡ് ഓൾ ഓക്കെ
Thank you, ma'am.
ഓക്കെ
Sunny, sir. I think there is some problem with the mic regarding Sunny, sir. So now let me invite Mr. Ranjit Prasad to deliver the lecture. Sir.
Okay, am I audible?
Yes, audible.
Okay, thank you. Thank you for such a warm and wonderful welcome. Let me share my screen. Are you able to see my screen?
Yes,
I hope you're, yeah, okay.
Yeah,
Thank you.
you can start now, sir.
Thank you so much for such a wonderful welcome. It is a privilege to be back in my college where I did my BTech, and it's to be coming back to discuss everyone on this special day and to possibly to learn from you guys. It's such an honor. So thank you. So also the two guys, the two legends, to make me go forward. So with that, I'll start with that. Okay, so what we're going to start, what we're going to discuss of the most important mathematician to have walked in the face of this earth. I would even go to an extent to say that there was an era in India before Ramanujan and there is an era after Ramanujan. He created such an impact. Take all the greatest mathematicians that is there in presently in India, and everyone must have been influenced some way or another by Ramanujan. And so that is why I want to his biography. I want to be able to go through some of his problems and puzzles that when I came across, I was baffled by it. I was confused. His favorite and famous summation. This was sent to G.H. Hardy, who was obviously Ramanujan's mentor, and in the letter, and this was the summation. So the summation goes like it's pretty simple if you see it is a summation of all the natural numbers. It's 1 plus 2 plus 3 etc. up to infinity. So when I thought when I saw the summation and I was thinking what possibly could be the answer for this summation, right? Because it's the one possible explanation that came up to my mind was, since it is all the name approach was, since it is all the positive numbers and it is adding up to infinity, so it probably should be infinity, right? I mean, infinity plus anything is infinity. So that was what I had in mind. But obviously it is Ramanujan, so there is a twist. So the answer for this is minus 1 by 12. So this got me confused because we are adding positive numbers and it should at least be a positive number, right? So why is it a negative number, and let alone a definite negative 1 by 12? So that is, so I wanted to say this to share to you the fact that this was done by a 23-year-old guy and is sent to a professor who was world renowned. He was G.H. Hardy was one of the most famous mathematicians in the late 19th century and early 20th century. So he was confused by this, and I can actually prove this. This is actually also just so you know, the summation that we use here is not regular summation. It's something like C0 summation, which is like, you can say, a parallel universe of summation where where we use is limit to define summation which converges, because which does not converge, because as you can see in the summation, this is a ever increasing summation, and it is obviously a diverging function. And I can give you a heads up or word how you can proceed. There is, you use two summations. One is 1 minus 1 plus 1, which go up to infinity, which is a oscillating function, and the other one is 1 minus 2 plus 3, etc. up to infinity, which is again a divergent function. And if you play around with it, you can get it. And you also use count, but then that is something else that is not for this discussion. But the point I'm trying to make is, he was a 23-year-old guy, and he made the one of the greatest mathematician question, puzzled. And we are all, what, I'm pretty sure the people who are listening to me are what, 21, 22, and around the same as the age as Ramanujan, and I'm 25, and I can't even think of possibly in my dreams come up with something as brilliant as this. So with this, I guess I can start with his biography. So Srinivasa Iyengar Ramanujan was born in 22nd December 1887. He was born in his grandmother's house, and he was soon moved to where his father lived. And he was considered a miracle child. He was considered a miracle child because his father and mother had three other children before him, and they all died due to infancy. And Ramanujan was the fourth child, and he survived. So he was basically the miracle child in his family. Even though he was a miracle child, he was born into a place of poverty. Because his father and mother didn't earn much. And so I wanted to emphasize on the fact that he was poor. He had no means of mathematical knowledge, people who were behind him or anything. Still, he achieved whatever he's achieved, and that's what makes him one of the greatest mathematicians there is. So Ramanujan, from a very young age, was a very devoted Hindu religion believer. One of his famous quote was, "Equation has no meaning to him unless it is a thought from God." So he was an ardent believer of God. He was also he was fascinated by numbers right from a very young age. He considered numbers to have some kind of a personality and some kind of movement, and that is how he defined numbers. And that for him was so right from a very young age he was fascinated by mathematics. But it is when he was in school, there was a book that was gifted to him, that is a synopsis of elements of results in pure mathematics by Carr, another famous mathematician. So this book basically listed theorems uh, without proofs of several theorems, just stated it like that, of areas ranging from algebra, trigonometry, analytical geometry, calculus, topology, all these places. So it had wide variety of areas in mathematics. And for me, it was not a good book because it didn't had any proof, or it didn't had. But for Ramanujan, it was one of his best book, because what he did was, he not only proved whatever there is in the book, each of these formula by himself, he also derived many new results and recorded them. So that according to me is his biggest quality, because right now we live in an era of internet. We have everything available on internet. It's just a click away, right? So we never think to ourselves. We never think whether we can solve it on our own. But Ramanujan solved everything. He discovered many of the old, whatever there was notebooks of Ramanujan, and whatever there is in notebook, it was already being discovered maybe years back. But what made it special was that he discovered it on his own. So that is what made him special. So he learned college level mathematics by age of 11, and he generated his own theorems in number theory, and his Bernoulli's number by age 13. See how brilliant he is. He also independently rediscovered Euler's identity. Euler's identity is considered one of the most beautiful equation in the world. And for me, it is, because look at the elegance of the equation. It has all the elements in a very pretty, concise form. We have E, I, complex number, irrational number, natural numbers, all those whole number, everything put together in one single equation. And I don't think there is any other equation which does that. But also, this is one of the most famous and one of the most important equation in mathematics. And Ramanujan independently discovered that, and that is brilliant. So even though he was an exceptional student in mathematics, his family background was very poor. So he couldn't, go pursue or, go somewhere else and pursue something else. So what he did was he joined government college of Kumbakonam, and as in arts, in English and mathematics, and he secured a scholarship, and that is how he was able to attend the college. This is his college, and he joined Government Arts College. So, but the problem was he was so preoccupied, he was so passionate about mathematics that he couldn't find his time for any other things like uh, English or Sanskrit, and he was not. Hence, he failed in all those things, and hence he was not promoted to senior FA class. So that I wouldn't advise on you guys, but I really think that the whatever he was so preoccupied. There was a reason for this. He was such a passionate person in mathematics that he couldn't find his time for anything else. So what happened was he lost his scholarship, and therefore, since he was from a very poor family, he couldn't continue his education, and he had to discontinue his education. So he after discontinuing his education, he tried his hands on tuition. He tried to give tuition to students, but then I guess he was way too advanced for all the students, so he failed in that. He tried several other things right from the age of 18 to 24. He tried various other things, but it never really worked out. So he finally joined as a clerk, like around 18 to 24, in between that, and at rupees 20 at that time it is big. So and he joined there as a class, and he independently started pursuing mathematics on his own. So, okay. So there is this very famous journal at that point of time in mathematics called Indian Journal of Mathematics, and what that journal comprised of was various, obviously various, lectures, articles by various famous mathematicians in India, but also it had a column on famous they can give puzzles and they can give equations, and they have to, and it is given as a challenge, and and the next week if someone solves it, they can give the solution. So Ramanujan used to give this if this puzzle. So one such puzzle that he gave was this puzzle: x is equal to root of whatever it is there. And I'm can somebody try it out and say what possibly can be the answer? It is it is I would say this, it is a very it is a very hard problem, because at that point nobody or anyone in the top mathematics category couldn't solve it. Nobody could solve it, and after 2-3 years, 2-3 weeks, Ramanujan has to share the answer with himself. But if you see the answer, you will see how elegant and how simple the answer is, and it put all the top mathematicians in India to shame, because it was such an elegant and it is such an easy proof. So since let's see the answer for this question. So as you can see, it is the answer is 3, and you can see how simple it is. It is I'm pretty sure any school level students can understand this very easily, right? And that is, I guess, the brilliance of Ramanujan. And because of this, he was noticed in the mathematics world. He was being recognized for all these things. But even though he was recognized, what made him come in the forefront of the Indian Mathematical Society was his paper in 20 at the age of 23. which entitled Some Properties of Bernoulli Number, which appeared in Journal of Indian Mathematical Society. And this actually put him in the forefront of international mathematics. And because this paper was such a brilliant paper, it obviously talked about Bernoulli's numbers and all those things. And he also, what made him connected to Hardy, who was his mentor and one of this major part of Ramanujan's success was after him going through a paper made by this mathematician Hardy, and in which he claimed that there is no definite expression for prime numbers, while Ramanujan derived an expression which is very nearly approximated to the real result. So he sent his response back to uh, back to Hardy, and G.H. Hardy, he actually sent it to several other mathematicians, but nobody really went through it. But it was G.H. Hardy who saw his potential and really, took him in under his wings, we could say. So G.H. Hardy, the role of G.H. Hardy in the life of Ramanujan is immeasurable. It is beyond praise. I would even go and say that if it wasn't for G.H. Hardy, we wouldn't be able to see Ramanujan. And I'm pretty sure if there is more G.H. Hardys in the world, there'll be more Ramanujans in India too, right? He was convinced from the first look that Ramanujan was a natural genius, and he has to be brought to Cambridge, because in India he couldn't really maximize his potential, and he had to be brought to Cambridge and to work together. So GH Hardy is, let me just tell that GH Hardy is a mammoth of a mathematician himself. He was considered one of the biggest mathematician in late 19th century and early 20th century. But whenever now, at least as an Indian, whenever we think about GH Hardy, we always think him in terms of Ramanujan. And by the way, this is, as you can probably see, this is not Ramanujan. This is I couldn't see a photo which is similar to, which had both of them. So I picked from the movie, which had Dev Patel, obviously, and the guy who played, which I probably don't remember the name. But yeah, so this is from the movie The Man Who Knew Infinity, which is about Ramanujan. So yeah, so whenever we think about G.H. Hardy now, we always think in terms of Ramanujan, right? So that is, and I think that is such an honor to have. So Hardy, according to Hardy, a single look was enough to consider Ramanujan as a brilliant, because he immediately recognized Ramanujan's mathematical genius, and he compared Ramanujan's to mathematical giants such as Euler and Jacobi. And Euler in the field of mathematician he is one of the biggest mathematical genius ever to be born in the earth. He is like I would say, the Einstein of mathematics. He played such an important role. And whenever you go through the school textbook or college textbook or PhD textbook, you will always come across Euler in some way or another, and Jacobi too. So once there was this famous quote that someone asked G.H. Hardy how to scale mathematician on the scale of 0 to 100. So Hardy gave himself a score of 25. Littlewood is his one of his best friend, and another mathematician, which is he's shown in the picture, he gives Littlewood 30, Hilbert an 80, and Ramanujan an 100. So you see, the one of the greatest mathematician gave Ramanujan a score of 100, and that is really awesome. So before going to the Cambridge, he had written around 3 notebook worth of contents of proofs and all the ideas that he had. And these 3 notebooks were published as a 2-volume set in TFR. And these 3 volumes had so many amazing formulas that Hardy had said it would take a lifetime to create such a book. So the fourth notebook, as in essential, is much more relevant nowadays because it's famously called the Lost Notebook. It was discovered only 40 years later. It was sent to Hardy by his wife after his death, but it was only discovered 40 years later. And now, even now, we are still figuring out some of the things Ramanujan not, because it is way too advanced, and we are still trying to figure out. We are still trying to prove all these things, and the equations that are there in the notebook is still being used. It is still being used in black hole theory. It is used in string theory and all those things. So it is still relevant. Though whatever he has done is still relevant. So even though uh, Ramanujan was did brilliantly in Cambridge, there was so much difficulties that he faced. First of all, the work that Ramanujan did and Hardy did was completely different. Ramanujan was a experimental mathematician, while Hardy, on the other hand, was more of a theoretical, or the way that usually how mathematicians work. Ramanujan played with numbers, and he played with examples. He wrote so many things, and he finally got something, rather than going in a rigorous proof manner. While Hardy, on the other hand, had some kind of a rigorous proof because he was taught that way. And there were so many work difference between Hardy and Ramanujan. Also, he couldn't handle the cultural differences that he faced in India, and from coming from an Indian background to a Western background. For example, he was a pure vegetarian, so he couldn't handle the food in in Trinity College where he was born, where he stayed. So he couldn't handle that, and he couldn't handle the cultural differences that was there. So so he had been in and out of hospital in the 5 years that he had been staying there. So he was diagnosed with tuberculosis in 1970. So after the diagnosis, Hardy wanted Ramanujan to be in the Royal Society, fellow as a fellow of Royal Society. Royal Society is like, I guess, the elite position, most elite position that a mathematician can get. It was one of the biggest position, and no Indian has ever been in that position. So Hardy wanted Ramanujan to be in that position, and because Hardy was such a prominent person in England at that time, he could convince the people, and Ramanujan was elected as a Cambridge Philosophical Society fellow, and 3 days later he was elected as a fellow of Royal Society. And this was mainly due to Hardy's campaigning and his pressure and because of his power in England. And this is something that I need to mention because he was able to achieve all these things, and we were able to understand about him because of one person called Hardy. So you have to appreciate the people who are there in your life. So I hope you got that from there. And this was so yeah. So Srinivasa Ramanujan was elected as a fellow of Royal Society, and he was the first Indian to be elected so. So and then he was already very famous, but then after electing as a fellow of Royal Society, India then gave him a chair. So which is kind of, I think, not fair because he was never recognized before that. But yeah, so it was he was elected. And okay, so I told you Ramanujan was fighting with his physical illness. He was in and out of hospital for a way too long period of a time. So he had to deal with all the problems, all the cultural difference. So once he was in a hospital, this was told by one of our students, but then I'm gonna repeat a slide and I'm gonna modify it. I'm gonna extend it to some more. So Hardy came to visit him in a taxi cab number, which is shown here in 1729, and Hardy, said this number is a bad omen. This has no this is one of the most uninteresting number, right? It's just there is no nothing we can connect with this number. So Ramanujan instantly replied, no, no, no. This number is very important. It's the smallest number which can be expressible to write as a sum of uh, cube two cubes in two different ways. That is 9 cube plus 10 cube and 12 cube plus 1 cube. So it can be represented as that. So this story is mainly told to say how brilliant he was and how he was fascinated with numbers. But there is a little more to it, and this was written in Hardy's textbook. So after this, Hardy thought for a while and asked, "Can you find something for the fourth power?" Obviously, because they are mathematicians, they generalize stuff, right? So Ramanujan thought for a while and he said, I don't know. I'm not sure about that, but if there is something, it will be very, very large. And it was in the order of millions, and it was a very big number. So nobody has found the fifth power yet, like which can be expressed as a sum of two fifth powers in two separate forms. So one of you possibly may be able to solve it. Who knows? There must be a Ramanujan in the Zoom in the WebEx call right now. So yeah, so I this got me into thinking, why was Ramanujan, how did Ramanujan instantly come up with that number, right? I mean, obviously he's a brilliant mathematician, but then there must be something that was going on, and that must have made him say that, instantly say about this number. And that is when I came across this paper, and as you can probably, and many other mathematicians, this is written by Ramanujan. And if you go to the the bottom right corner, you can probably see that whatever it is written, 9 cube plus 10 cube equal to 12 cube plus 1 cube. So you see, he was he was already working with that number, so he knew about this number. So I was thinking, why he was, doing this number, and why was he working with this number? And like many other mathematicians, he got to know that he was working on a mammoth of a theorem called Fermat's last theorem. For the people who don't know, Fermat's last theorem is known as the biggest, one of the most difficult mathematical proof and mathematical equation known to man. It was unsolved for more than 350 plus years, and it was solved recently by Andrew Wiles in 1995, I guess. And it was, I guess, the first computer generated proof. It was made completely by computer. So and people went through this, whatever Ramanujan has written, and it was kind of where it was going, like the whatever Andrew Wiles used. Andrew Wiles used Ramanujan's formulas as reference to prove Fermat's last theorem, and he was going in the right direction. So maybe if he would have lived for more than, let's say, 50 more years, he would have probably solved Fermat's last theorem, right? So yeah, so you see, he was already solving things, and he was already using things which are not even formed yet. So that was I for me pretty remarkable. So yeah, so as you can probably uh, know that Ramanujan, from a period of, like, the period he lived, like around 5 years, he was in and out of hospital for almost all the time, and he, because of the cultural difference, because of the food, and he was malnourished and all those things. So he was very, very ill. So at one point he became very ill that Hardy suggested that he go back to India and solve his health problems and then return back, because in India he don't have to worry about all these things, right? So in the hopes that he gets better, Ramanujan was persuaded to return to India, and then come back to Trinity College. So Ramanujan went back to India at 27th February 1990 at the age of 31. But unfortunately, his precarious, very dangerous health did not improve on his return to India, and despite best medical attention given to him by doctors, his very untimely death occurred at 26 April 1920, and when he was merely 32 years old. He was only 32 years old, and look at the legacy that he has created, right? We are still talking about Ramanujan. We still celebrate him, and that is because of the and imagine what he could have done if he had been, let's say, 8 year old or something like that. He was survived by his wife Janaki, who lived until her death in 1994, along with her foster son W. Narayanan. So yeah, this was Ramanujan's the whole life. So he only lived like up until 32 years, and even then he has put forth so much that he created an era for mathematicians. He inspired so many people. He inspired so many generations of mathematicians to come, and that, according to me, is the brilliance of Ramanujan. So many books and movies were made of him. So one such movie which is very famous is The Man Who Knew Infinity, which had Dev Patel and Jeremy Irons, which is the name of the man who played GHRD. Now I know. And there was also this Tamil movie, which is again The Man Who Knew Infinity. And this movie, which starred Dev Patel, was made from the book The Man Who Knew Infinity by Robert Canigal. And it was such a masterpiece of a book, which told the real story. I've read the book. I haven't personally seen the movie, but I've read the book, and it is such an amazing book. So I personally think everyone should read the book. And so yeah, this was made as a tribute to him, the tribute to the genius. So before concluding, I want to add some more things, and I want to add one more puzzle, which is a very famous puzzle, and which had Ramanujan and his brilliance. So you can probably see from here. So this is Ramanujan's magic square. So can you say something which is special about this? What I want to know, I hope you guys know what is magic square. So magic square is basically every row add up to a particular number, every column add up to a particular number, every diagonal add up to a particular number. So that is a regular magic square, but Ramanujan's magic square had to be something special, right? So let's see what is so special about Ramanujan's magic square. So the sum of the rows add up to 139. Oh, yeah, that is magic square. So there is nothing new about that. So what is so great in it, right? Uh, so every column add up to 139. Again, magic square had that property. So nothing very special about that. Every diagonal add up to 139. Yes, 22 plus 17 plus 89 plus 11 add up to 139. Add all the corner elements, that is 22 plus 87, 11 plus 90. It add up to 139. Now it's a bit interesting. If we add all those numbers which are colored, 12, 18, 86, 23, that add up to 139, or the other, which all again add up to 139. Awesome, right? And if you add this, again add up to 139. Inside the square, again add up to 139. Finally, do you know what's the relation between this magic square and Ramanujan? Look, check at the first row. This 22, 12, 1887. That is his birthday. And that is amazing, right? And obviously, that is what makes Ramanujan Ramanujan. And the sum is equal to 139, a prime number, obviously, because it's Ramanujan. So we have to make it a prime number. So obviously. Okay, so I want to end this by saying asking you guys, how many of you know about string theory? Like, if anybody know about string theory, what string theory is? I mean, obviously, nobody in the world really understands string theory. It's still a theory and it's still a it's still a in its very naive form. But I want, like, I hope you guys have like a idea what it is about. So basically string theory is a is basically a theory about everything. It's a theory. Physics have so many forces: gravitational forces, electromagnetic forces, nuclear forces. So physicians around the world, scientists are trying to find a theory about everything, which combines all these forces and put a force which has everything. And string theory is the best contender for this theory, for this theory of everything. And the equation that came up in string theory is Ramanujan's summation. But then people may not know. So I want to ask how many of you here use mobile phones. So, and if someone says no, I'll freak out, because I'm pretty sure everyone uses mobile phone, because that is how you access this, or laptops or anything. So one of the most advanced cellular protocol, graph protocols, uses it was made by a famous electrical engineer, and he got Kirchhoff Prize, which is like a big prize in electronics engineering. And this again had a, this again had a part of Ramanujan summation, the summation that I used to code in the beginning: 1 plus 2 plus 3 plus etc. up to infinity. So you can see that like it's still being used. It is this protocol is one of the most advanced protocol. It's not even, you know it's not even old. It's a very new protocol, and that uses that uses Ramanujan summation. Black hole theory that had Ramanujan summation, Ramanujan's equations around. And I guess that is what makes him relevant. That is what makes him really, still an important part in Indian history, because his theorems, his problems are still being used, are still being tackled regularly to understand, and we are still yet to understand him completely. But I'm pretty sure on the years to come, we'll be able to appreciate him more and to understand how brilliant of a mathematician he was. So yeah, this is the legacy that Ramanujan created. So I hope you understand the importance of Ramanujan. Why we celebrate 22nd December as National Mathematics Day and not some other day, because of Ramanujan. And what I want you guys to get from here is that he achieved all those things because he discovered things. He had his mind to go out and seek and explore. Now you guys have that opportunity. Now you guys have Mathematics Club, and now you have such an amazing bunch of people in FISAT, in as in the in the at least in the mathematics department. I know the people are the best. I mean, you have a vice principal who is a mathematician. You have a dean who is a mathematician. What more do you want? And I think that is, uh, you have the privilege. And I'm not saying you have to be poor to achieve all these things, but then I'm saying you have to realize your privilege, and you have to understand your privilege, and use them when you have that choice. And trust me when I say this, mathematics has helped me so much right from my BTech, since I used it when I went to Tata Alexei for my job, and now when I'm doing my MTech. In MTech, the major portion of my first semester was linear algebra and probability. And I'm studying computer science, MTech in computer science, and that subject is not even there. Like it is a very minor subject, but the major subjects were linear algebra, probability, and all those things, because they want us to have a proper base in mathematics. Because if you don't have mathematics, then you really can't do anything in computer science, because computer science, in my opinion, is an application of mathematics. Not just computer science, take electrical engineering, take electronics engineering, everything will have some kind of mathematics involved in it. So please make use of this opportunity. When you have this club, when you have this opportunity, please make use of it. And when you go to the campus placements, the first session which everyone has is aptitude round, which has mathematics. Since I went to all those competition, I was very eased with all the aptitude session. The coding is basically mathematics. For me, it is mathematics, and it is just a mathematics, but still an application, graph theory, and all those things is applications of mathematics. So please make use of this, and I hope you learned something and you understood something and you got to take away something, and you will be able to appreciate mathematics a bit more from this session. If one of you are able to do that, I will be very happy. So thank you so much for listening. And any questions? I would say that ask your teachers, because for me they are my role models and they are the ones who inspired me to do something. You have such a great bunch of people around you and to ask questions. I really want you guys to really get involved in mathematics club and make use of this platform when you have the time. So anything in this presentation, if you have any doubts, please do let me ask. Or if you're shy enough, you can contact me in mail, and my mail ID is I'll tell you, it's ranjitprasadk4@gmail.com. So you can contact me through that also. I'm sorry I didn't put it in here, but then if anyone wants that, I'll be very glad to help you guys in any way possible, anything related to mathematics or anything. So thank you so much for having me. This is such a privilege, and I'm dedicating this to Shinoy sir, because even though he's gone, look, we are still talking about him, and that is for me such a honor to talk about him. And I'm pretty sure as far as FISAT is there, his legacy will still continue, and he'll be still remembered as one of the best teachers that. Ma'am.
Any questions from the audience? Thank you, dear Ranjit.
Hello.
Thank you.
Am I audible?
Yes, sir. Yes, sir. You're
Audible.
Hello, Ranjit.
Yes, now I can
Yeah.
hear you.
Okay, Ranjit. This is not really a question. Since you started the lecture with
Yeah,
with the Ramanujan summation, I just want to throw a little light on the electronics and communication part of it. In 2015,
yeah.
there was a paper released by the famous scientist Vaidyanathan. I don't know if Ranjit knows it. Vaidyanathan is from electronics and communication background, and he is the author of the famous book on multi-rate systems, multi-rate signal processing. And the paper was named Ramanujan filter bank, and it was a filter bank which is used to estimate periodicities in sequences in one-dimensional or two-dimensional sequences. The paper was released in 2015, and after that a lot of people, since the paper was introduced into the research field, a lot of people worked on it, and I could even see a paper in 2020 based on Ramanujan filter bank. And just to add something to your lecture, Ramanujan summation still remains relevant in the field of communication and research. And thank you so much for the enlightening lecture. I was very much, you got us really involved into the lecture. Thank you.
Thank you. And that is what I was going through. I was going through when I talked about the the communication or the networks that were being. I told who uses mobile phones, so that was I was getting it. It was P.P. Vaidyanathan who used all these protocols, and he invented, discovered that. So yeah, thank you.
Thank you, Basil sir, for the information you shared with your former student as well as your junior present students, sir. Thank you very much for your participation.
Thank
Any
you.
more questions?
Thank you, miss.
Any more questions from audience part? If at all you don't have any questions presently, you can meet your senior Ranjit Prasad at any time for any help. Is that okay, Ranjit?
Yes,
Okay,
yes.
sir.
Please do talk to, mail me or call me anytime. I'll always be ready to help for any way, gate or, non-gate or related to mathematics anywhere. I'm always ready to help. Thank you for having me.
Okay, thank you, sir, for your inspiring and motivating words. Thank you,
Please
sir.
do call me. Please do call me Ranjit. I don't call me. I feel very bad when ma'am calls me Ranjit. Sir. Please do call me Ranjit.
Okay. Okay, even though you are our dear student, it's our privilege to respect you and show our gratitude towards that salutation. That's all. Okay, let me call you Ranjit. Okay. Thank you. Yes, yes, sir. And sir, പറഞ്ഞോളൂ.
Hello.
രഞ്ജിത്തിനെ കണ്ടതിൽ സന്തോഷമുണ്ട് രഞ്ജിത്ത്.
Oh, hello, sir.
ഒരുപാട് ഉയരങ്ങളിലേക്ക് എത്തിയിരിക്കുന്നു.
Hey.
വണ്ടർഫുൾ ടോക്ക് ആയിരുന്നു. രഞ്ജിത്തിന് ഇനി ആവശ്യം ഉണ്ടാവും. ഞങ്ങളുടെ ഓൺലൈൻ പ്ലാറ്റ്ഫോമിൽ ഇടയ്ക്കിടയ്ക്ക് വരണം. ഞങ്ങളുടെ കുട്ടികൾക്കൊരു ആർജവവും ഉന്മേഷവും കൊടുക്കണം. രഞ്ജിത്തിന്റെ മുഖത്ത് അതൊക്കെ ഞങ്ങൾ കാണുന്നുണ്ട്. ഞങ്ങൾക്ക് ഒരുപാട് കാര്യങ്ങൾ കോൺട്രിബ്യൂട്ട് ചെയ്യാൻ രഞ്ജിത്തിന് കഴിയുമെന്ന് ഞങ്ങൾ പൂർണ്ണമായിട്ട് വിശ്വസിക്കുകയാണ്. രഞ്ജിത്തിന്റെ ആ മൊബൈൽ നമ്പർ കൂടി ഒന്ന് ചാറ്റ് ബോക്സിൽ ഇടാമോ? ഓക്കെ. രഞ്ജിത്ത് പിന്നെ സുഖമാണല്ലോ അല്ലേ?
സുഖാണ് മിസ് സാർ. ക്ലാസ്സും എക്സാമും നടന്നുകൊണ്ടിരിക്കുക അതിന്റെ ഇടയിൽ. അപ്പോ അതിന്റെ കുറച്ച് ടെൻഷൻ ഉണ്ട്. എന്നാലും സുഖമായിട്ടിരിക്കുന്നു.
ഓക്കെ, ഞാൻ ഇടയ്ക്ക് വിളിക്കും കേട്ടോ രഞ്ജിത്തിനെ.
വിളിച്ചോളൂ സർ, വിളിച്ചോളൂ.
ഓക്കെ,
വിളിച്ചോളൂ.
താങ്ക്സ് എ ലോട്ട് രഞ്ജിത്ത്.
താങ്ക് യു സർ, എന്നെ വിളിച്ചതിൽ സന്തോഷം.
Anybody else to speak? So thank you, Ranjit, for portraying in front of us the passion that Ramanujan had with a much higher level of passion. Even though I know that you are so much into mathematics, it's very evident that quite a lot of effort was put into making this presentation. I would like to thank and convey my deep sense of gratitude for consenting to be here with us today. Now, before going into the formal vote of thanks, I can see Ms. Unnimaya, our former club secretary, has joined this meeting. I invite Unnimaya to speak a few words. Unnimaya?
Hi, Miss. Am I audible?
Yes, you are audible. You can speak.
Good afternoon, everyone. Respected priests. It's actually a pleasure.
Unnimaya, can you speak a little more louder?
Yeah, it's actually my pleasure to attend this event. It was very informative. Thank you so much, Ranjit.
Thank you.
He was my senior and it was very enlightening, just like Basil sir said. I'm so happy, I'm feeling so happy to hear all this. And being part of Maths Club had always helped me in many ways. I just joined it because of Shinoy sir. I remember he was my first group advisor. So he had started the club. At that time I had joined. But unfortunately he's not here, but he's being talked about, and that makes me it makes me really happy also that we are remembering him. And I want to wish everyone happy Mathematics Day. Then to all the students, I'm really glad all of you are here attending this meeting. I hope you all continue to attend all of the Maths Club events and go on to coordinate also many events. Attend different variety of maths events. It will help you in many ways. Like if you like mathematics, it's a joy. And more than that, it is helpful in many ways. Like just like Ranjit said, wherever you go, maths will be there. Like wherever you are going to study something, in whichever field, maths will somehow follow you. So the more you know, the better. And I hope you all always have a passion to learn. And for me, this was an inspiring talk. It inspired me to, go and search something, learn something. So after this, I will go and search about string theory and all. So it was really great. Thank you so much. Thank you so much for sharing the link that I could join. I want to thank everyone who have done this so well, Sina Miss and everyone. I just want to share my happiness. That's all. Thank you.
Thank you, Nimaya. Sir, Sunny sir.
Hello, hi Ranjit.
Hi, sir. Hi, sir.
I was listening to your talk. It was good. In fact, I had given a talk today morning to St. Xavier's College on Maths Day. Maths. It was really amazing to see you again. And you are doing MTech or not mathematics, right? MTech in EC.
Computer science. Computer.
MTech in computer science. Yeah, good. So you are going to realize that mathematics is closely blended in all kinds of all disciplines of knowledge, not only engineering but also all other things. So you'll be excited as Ramanujan when you come across such wonderful things. I wish you all the best. Thank you.
Thank you.
Thank you, sir. Now let me conclude. Let me invite Ms. Anubama for the vote of thanks.
Hello, ma'am. Audible ano?
Yes, Anubama, you can continue.
I am Anupama from S3CS department. Being a member of Max Club FISAT, I consider it as an honor and privilege to extend the vote of thanks. Once, a great man whispered, feeling thankfulness and not expressing it is like wrapping a present and not giving it. Today, I take this opportunity to put all my words into gratitude. On the behalf of the management and students, I would like to thank our chief guest, Mr. Ranjit Prasad, for taking his precious time out and consenting to be the chief guest. Indeed, it was a wonderful talk. I express my gratitude to Dr. C. Sheila, who has graced us with her presence and support. Thank you, ma'am. I thank Ms. Sina Verghese, staff in charge of Max Club FISAT, for her untiring efforts in conducting this event. Thank you, ma'am. I thank Sir Sunny Kuriakos, all the multimedia staff, former members of Max Club, teachers and others for showing the interest and turning up this program. I once again thank each and everyone in making this program a success. Thank you.
Again, thank you one and all for your active participation. Thank you all. Thank you.
Sina Miss.
Yes, sir.
എന്റെ പ്രത്യേകം താങ്ക്സ് സീന മിസ്സിന് കേട്ടോ.
Okay, sir. Thank you.
പ്രോഗ്രാം കോർഡിനേറ്റ് ചെയ്തതിന് കേട്ടോ.
Okay, thank you.
Okay, miss. ഉണ്ണിമായ പോയോ? ഉണ്ണിമായ പോയോ?
ഇല്ല സർ. അവിടെയുണ്ട്.
ഓക്കെ ഓക്കെ.
ഹായ് സർ, സുഖല്ലേ?
ഉണ്ണിമായ.
യെസ്.
ഉണ്ണിമായ ഇപ്പൊ എവിടെയാ?
ഞാൻ വീട്ടിലുണ്ട്, വർക്ക് ഫ്രം ഹോം ആണ്.
ഓക്കെ. ഏത് കമ്പനിയിലാണ് വർക്ക് ചെയ്യണേ?
കേഡൻസ്.
ഓക്കെ ഓക്കെ. സുഖമായിട്ടിരിക്കണം അല്ലേ?
അതെ.
ഓക്കെ ഓക്കെ. താങ്ക്സ്. കണ്ടതിൽ സന്തോഷം കേട്ടോ. ഓക്കെ ശരി.
താങ്ക് യു സർ.
ഓക്കെ ഓക്കെ ശരി.
Okay, thank you all for joining. Thank you, Ranjit. Thank you very much.
Thank you.